In professional education, the mathematics of a traditional lecture hall are unsustainable. One instructor cannot provide meaningful, individualized feedback to 300 students simultaneously. This structural bottleneck is a severe risk in professional qualification tracks like the ACCA or CPA. These exams require absolute adherence to current international financial reporting standards. When a student struggles with a complex consolidation calculation, they submit their work and wait. It can take days to receive a graded tutorial back from an overworked faculty member. By the time that correction arrives, the student has moved on to new material. This delay breaks the cognitive link between making an error and understanding the specific misstep. Without real-time intervention, learners often abandon logical deduction. They default to memorizing past paper solutions, hoping to recognize patterns rather than mastering the underlying accounting principles. To close this feedback gap, institutions are deploying generative AI tools. Administrators see platforms like Google Bard or ChatGPT as a way to provide 24/7 tutoring at scale. However, conventional large language models are not designed for regulatory compliance. They function through probabilistic word guessing, predicting the next most likely token in a sequence, rather than reasoning through financial rules. This leads directly to AI hallucinations. A standard model can generate a convincing, logically structured explanation for a tax treatment that completely violates local tax law. In an environment where accuracy is the primary metric, unconstrained AI is an institutional liability. Managing this risk requires a specialized technical architecture. Retrieval Augmented Generation, or RAG, serves as the architectural standard for deploying AI in these rigorous academic environments. RAG operates by physically severing the AI's core processing engine from the unverified open internet. Instead, the institution builds a proprietary vector database to house its knowledge. This closed loop is populated exclusively with trusted materials, official IFRS texts, historical exam questions, certified examiner reports, and the exclusive notes of senior faculty members. When a student asks why Goodwill requires an annual impairment test, the AI does not begin drafting a response immediately. First, the system triggers a retrieval mechanism. It searches the database to locate the exact accounting standard and corresponding lecture notes addressing that specific query. Only after retrieving this verified data does the AI generate text. The system restricts the model to summarizing these retrieved facts, removing its ability to invent information. A RAG architecture also requires the AI to prove its work. By requiring the system to append the exact syllabus chapter or IFRS paragraph to its answer, institutions provide full auditability. The student can verify the source of every rule cited. By constraining the model to a verified knowledge base, RAG transforms a probabilistic tool into a highly authoritative instructional asset. Once the architecture is secured, the pedagogical application can be deployed directly into the student's digital workspace. Traditional automated grading systems typically evaluate a final answer. An AI-driven tutorial system evaluates the underlying cognitive process. This framework for Socratic prompting ensures the AI acts as a one-to-one coach. It is programmed to ask targeted questions that guide the student toward the correct methodology, rather than providing the completed financial statement. If a student incorrectly calculates deferred tax assets, the AI performs step-by-step debugging. Scanning the logic path, it illuminates the exact point of failure, like missing a corporate tax rate change. This targeted intervention ties directly to official grading rubrics and specific examiner marking points. Prompting the student to revisit that specific logical node and correct their own error builds the independent deduction skills required for professional practice. To ensure students master principles rather than memorizing questions, the system utilizes dynamic variable generation. The AI automatically swaps underlying constraints in classic exam scenarios, altering depreciation methods or subsidiary holding percentages, creating infinite practice configurations based on official source material. Socratic guidance and limitless problem variation force students to rely on professional judgment rather than recognition during every practice session. Within a university, AI acts as a filtration system that isolates and maximizes the specialized expertise of senior faculty. This operational model is managed through a human-in-the-loop, or HITL, three-tier escalation matrix. Tier 1 is the automation layer. Operating 24/7, the RAG-enabled AI instantly handles 80% of routine student queries, clearing basic definition requests, formatting guidelines, and primary calculation checks. In Tier 2, the system aggregates data from those interactions to provide predictive analytics. It can isolate class-wide blind spots, such as a high error rate regarding unrealized acrofes in internal transactions. Armed with this data, lecturers can focus their physical tutorial time on concepts that have been proven to cause cohort-wide difficulty. For individual student questions, the system operates on a strict confidence threshold protocol. When a query involves a complex gray area or a student cannot break a logical barrier, the system triggers Tier 3. The issue escalates directly to a human expert. These queries are packaged with the student's full conversation history and error logs, giving the senior lecturer the context needed for a focused, high-value intervention. This architecture removes the traditional link between student-teacher ratios and feedback quality. The routine workload is automated, while human expertise is reserved for the most difficult 20% of cases. Integrating retrieval-augmented generation within a human-in-the-loop framework allows institutions to optimize pass rates and focus faculty resources on high-level career